and not refer to it for the next 5 years and then expect you to remember it? Okay. And remember how I told you I don't like to be that teacher? Okay. Remember how yesterday? No, do the joke. Let's get it out of the way now.
Yesterday was Sunday.
Okay. On Thursday, I'm going to say tomorrow in class. I expect at least 5 of you to say, we have school tomorrow. And then I'll say, okay, Monday. And then I expect the same 5. We'll have school Monday. Okay, so just get these jokes out of the way now. I do the jokes here. Okay? I'm 45. I've heard all those jokes. What, Nino? No, nothing? Yes. 4-day week, 4-day weekend, 4-day week. I know we work you guys pretty hard. I quite frankly don't know how you manage to continue to get up every morning with the grueling schedule we put you through. 5 hours a day, 4 days a week. Man alive. Okay, first of all, by the time you retire, if you don't graduate high school, you have earned approximately $500,000 less than someone who has graduated high school. So don't give me no crap about how high school doesn't pay you. Do you all want... I mean, you're all welcome to drop out right now and then cut me a check for $500,000 when you turn 65. You're all welcome to.
I'm going to find a way to be rich.
Please do. I hope you do find a way to be rich. Everybody deserves it. However, by the same token, of course, none of you are going to come back when you're 65 and write me a check for $32,000, which is my portion of your high school education. Why not? Because you're not going to.
Well, rich people stay rich by not spending money.
That's partially true.
Maybe like $5.
That is partially true. All right. So what we did yesterday is going to apply right now, today. Okay? Okay. Let's talk. How do I find the area of a rectangle? What? How does that have anything to do with what we're doing right now? Trust me. Work with me. It does. Ezra, that's amazing. You made your voice go to like 5 different people without even moving your lips. You're better than that kid on Victorious that looks like Andy Samberg. You all know who that kid is. The kid with his hand up the dummy's butt. Rex is the dummy. I don't remember the regular kid.
Right. Does it start with an R?
Robbie. Yeah, it's Robbie. Yeah. He looks like Andy Samberg. Anyway, of course, you multiply length times width. Yes? Length times width. Now, since length is multiplying by width, what would you call those two things? They are indeed factors. Yeah? Yeah. Now, what if that rectangle is the very specific, special kind of rectangle that we name a square? Do we still do length times width? Yes, but what do we know about length and width if it's a square? They are the same. So would we use the same letter? No, because length equals width. So we could, if we wanted to, just say side times side, couldn't we? And if we wrote side times side, no math person would write that, would they? What would they write instead? Edward? S squared. So, if you are provided with the area of a square, how can you determine the length of each side? Well, it must be the area of a square must be what?
Equal. The same. Divided. Multiply.
The square root.
It must be 2 factors that are the same, right? Must be 2 numbers that are equal factors. Now, what we math people do, because we don't want to write that long a sentence, is we write this. Area equals side squared, and side equals the square root of the area. This symbol right here, which is not the square root symbol, which is what everybody calls it, because up till now you have mostly only dealt, with square roots. It is actually the radical symbol. And it is asking you to find equal groups of factors. This one in particular wants us to find two equal factors. And since it's only two factors, we call this particular one a square root. All right? Yeah? Yeah. Now, what if I wanted to find the volume of a prism? It would be length or width times length times height, right? W, L, W, H, H, W, L, I don't care. Wouldn't matter. What if it was that very specific kind of rectangular prism in which all the sides are the same, which is a cube? Would it still be LWH? Technically, would it be LWH? Yes, but we would not write LWH. Why? In a cube, L equals W equals H, so we would write S times S times S, which would be S cubed. Now, you're smart young people. If I'm given the volume, how do I determine the length? Well, if area equaled S squared, volume equals S cubed. If S equaled the square root of the area, what must S equal of the volume?
What was the question, sorry?
If area equals the S squared, and then S equals the square root of the area, cubed root of the volume. This symbol, please notice, is very subtly different from this symbol, yes? Is it still a radical sign? Yes. So does it mean I'm looking for groups of factors? Yes. But in this case, because of that little 3, I am seeking 3. Groups of 3, not groups of 2. So this symbol is asking me to find groups of 3 equal factors. That little 3 is called and this is a new word, I think, for a great many of you, the index. Please highlight it, underline it, put a Mrs. Bad Crumble cloud around it. I don't care what you do. I'm going to use that word a buttload over the next few days. You need to know what I am. I almost dangled my preposition in front of you. You need to know what it is to which I am referring. Okay? Okay. A perfect square or a perfect cube is any number which has a rational root. What do you mean, Mr. Myers? I mean things like the square root of 4, which is what? 2. That's a perfect square. Or the cubed root of 8. What's that? 2. That's a perfect cube. Now here's where it gets a little weird. Does is x squared a perfect square? Why?
Because you don't know the number, so you just assume that it has a square root.
It has to have a square root because the square root of x squared would have to be x, wouldn't it? Because it would be x times x. Is everybody good? Page. Because 2 times 2 times 2 would be 8. We are seeking a group of 3 factors there.
Oh,
Okay. Now, I haven't taught you this yet. Maybe you know it already. But let's just play around a little. Is the square root of 2, is 2 a perfect square? No, because the square root of 2 is irrational. Is 1 a perfect square?
Yep.
Yes, why?
It's 1 times
1 times 1 is 1. Is 1 half a perfect square? No, why not?
I don't think it can be square root for
There's no square root for...
half of 1.
Right. Is 1/4 a square root? A perfect square, I mean.
Yeah.
Yes, why?
0.5 from 0.5.
Because 1/2 times 1/2 is 1/4. All right, good. Everybody's cool with that?
How does that work?
What do you mean, how does it work?
Never mind.
Okay, good, I'm glad.
Multiplying incorrectly.
Now, perfect squares and perfect cubes are very prevalent in future math. And they are one of those things, like your times tables, if you actually have them memorized, you're in very, very good shape. Okay? So, that's what I'm saying right here. It is a very good idea to memorize these. Most of you know a lot of them. You don't know all of them. We're just going to write them down, and then we're going to do something with it. So, when you turn to page 26, list the perfect squares from 0 to 400. So, we'll start with the squares. Are the squares the bigger number or the smaller number?
Bigger number.
The bigger number, because the square root is what it comes from. So we'll start with the roots. The first number is, do we need 0? No, because 0, 0, 0, big deal. We'll start with 1. There's the root. What's 1's square? 1. What's the next number? 2. What is 2's square? 4. What's the next number? 3. What's 3's square? 9. 3 times 3. Carry on until the top numbers are 400. You already know what it is, but carry on anyway. 4, 5, 6, 7, 8, 9, 10, 16, 25, 36, 9, 64, 81, 100. Now, I would argue there are perfect squares not there, right? Like we already talked about how 1/4 is a perfect square, right? And that's not on our list, yeah? So for our intents and purposes, perfect squares generally means integers as opposed to rational numbers. Okay? We're going to do something with this in a minute, but that's where we're going to stop. Of course, you should notice a pattern. +3, +5, +7, +9, +11, +13. We'll carry on. This one was plus 39. So what is 21 going to be?
441.
441, because I added 41. What's 22 going to be? 484, because I add 43, and so on and so on and so on. But I recommend knowing these first 20.
Could you explain how that worked one more time?
I added 3 to get to 4. Then I added 5 to get to 9. Then I added 7 to get to 16.
Oh, just
So this last one was 39. So I must add 41 to get to the next one.
so it goes 3, 5, 7, 9.
It goes up by odd numbers. Now, perfect cubes. Well, same thing. 1, 1. 2 cubes. 8. 3 27. 4 64. 5 6. Oops. 7 343. 8 512. 9 729. And 10 1000. There's lots of tricks to multiply. What he's doing, I would guess, for example, 8. 8 times 8 is 64, automatically, because he knows it from up here. So he's just doing 64 times 8. And my guess, he's doing 60 times 8, which is 480, and then 4 times 8, which is 32, and then adding them to get 512. Am I right? There's nothing to get, Paige. These are just cubes. This number cubed equals 8.
I like taking the long route to get answers.
You're welcome to take the long route to get answers. That's all we're doing here. We're going to do something else with it in a minute. But first, I want to point some things out to you. For example, you should notice that 400, if I were to break that down into... Actually, I'm not going to do that yet. If I were to write this symbol over 400, you know the answer is 20, yes? Right? Because of what we just did. 20 squared is 400, so the square root of 400 is 20, right? I want you to notice some things. 400, isn't that the same as the square root of 4 times 100? It is, isn't it? What is the square root of 4? 2, right there. Times, what is the square root of 100? 10. 2 times 10 is what? 20. Please notice the relationship. Does everybody see this? Okay. What if I were to ask you for the square root of no, I don't want to do that. We'll do that later. Will the same thing apply here, do you think? Will it? It will in some way, because how does math work? It's all patterns, right? It never changes. So somehow this knowledge will help us here. Everybody cool? Now, what is more common? A perfect square or an irrational? A perfect irrational.
Yeah, I meant to say irrational.
Irrationals are more common, yes? Okay. So most of the time you're going to be dealing with something like this. Now, when you see something like this, you all automatically go to your calculator, you punch in, you get an answer. Always. But That's not a rational number, is it? So is the answer that you get from your calculator the actual answer? No, it's an estimate. All right? So right now, up until now, if your math teacher gave you that, just that was the whole question, wasn't it? You went square root 72 equals, and you wrote down an answer and your teacher gave you the gold star, right? Right? Math 10's not like that. This is one step along the way. This might be one step of 15 steps you are going to do. How many of you have ever texted poorly? All of you need to put your hand up. All of you have.
Like with swear words or like in
No. Texted something that wasn't what you wanted to say. Of course, all of you need to put your hand up. You have all done that. Why? Because when you are typing a bunch of things into your phone very quickly, it is easy to make an error, yes? All right. Autocorrect does not always save the day. All righty. So, I would like to make sure you have a tool available to you to have an idea of where you are going before you sit down with your calculator. And that's what we're going to work on right now. We all agree that the square root of 72 is not a perfect square, yes? Because it's not on our list. But it is between two perfect squares, is it not? What is it between? Yeah, because it's between 64 and 81, yeah? Which means the square root of 72 must be between 8 and 9, yes? How far? Well, how far is it from 64 to 72? That is 8, right? And how far is it from 64 to 81? 17. So I have taken 8 out of a possible 17 steps, yes? Which is 8 divided by 17, which is approximately half, yes? So our guess here would be 8.5. And when you punch that into your calculator, square root of 72, I believe it comes out as 8.47. Somebody do that with their calculator right now. 8.48, son of a... I'm fired. Does everybody see how this works? Now, some of you will say to me, rightly so, Myers, why the heck would I do that? I would just punch in root 72. And you're right, you could just punch in root 72. But sooner or later, you're going to be faced with equations and calculations where that is not the only thing. That's just another number. So you should have an idea of what it will be. So when you punch everything into your calculator and you get an answer, you will know if that answer makes sense. Paige. Of course, that's your first time this week. You're going to use it on Monday while I'm teaching? Okay. So, everybody should know what to do with 180 now, yes? What is 180 between? It's between 169, which is 13, and 196, which is 14, yes? How far is it there? 11. How far is it there? 37. It's pretty close to 12 and 36, isn't it? 27, that sounds better. It's pretty close to halfway again, isn't it? Little less, right? So 13.4. Check it on your calculator. What is it? Because that's what she wants to do. Don't pencil shame her. Wow. It's almost like math works all the time. So, you're all going to do C right now. Go. So what is it? 17.3? Because that is between 289, which is 17, 324, which is 18. That is 11 out of a possible 35, right? 11 is pretty close to 12. 35 is pretty close to 36, which would be 12 over 36, which would be 1/3, 17.3. Good guess. Does anything change down here? Does anything change in our methodology? What we're going to do? No. The numbers change, though, don't they? Because we're not looking at the squares anymore. What are we looking at? The cubes. So this is between 27 and 64, right? Which is 3 and 4. But everything else is the same. It's 18 out of 37, which is about half, right? It's 18/36 is a half. So that would be 3.5. Everybody cool? Yeah. 405, that's between what? 7? Oops, sorry. Yeah, because 343. 343, 7, 5, 12, 8. Now, the numbers are getting bigger. As Abby said, this is harder. Again, I'll say to you, what verb is that? What does the verb estimate mean? Make a guess. So this is about 60, isn't it? 60. This is about what? 170? Isn't 60 about 1/3 of 170? But a little less, right? So maybe 7.3 instead of 7.33. Good? And then this one, 176, that's between 125, which is 5, 6, which is 216, which is 6. That's 50, right? But 50. And that's what? 90. Right? Right? So 5 out of 9, 50 out of 90. Very slightly more than half, yes? So 5, you could say 5.6. I would probably say 5.55, but whatever. That's not the point, right? Exactly. Now, if you were punching in a whole big long thing on your calculator and this was part of it, you would know you could multiply by 5.6. And then when you're estimating, you would say, well, maybe I don't want to multiply by 5.6. Maybe I'll actually multiply by 6. And then you would get an answer that is close. Then if you punched the whole thing into your calculator and had something way out to lunch, would you write it down? No, of course not, because you've taken an extra 1 second to do an estimate so you know approximately where it is you're going. Right? Okay, Paige. That's why I say you would memorize them. It's a good idea. I'm not saying you have to. I'll never grade you on memorizing them. And Paige, I'm glad you asked that question because somebody always does. Guess what the very next thing we're going to do is? How to do these properly without memorizing anything. No, tomorrow. After you write your quiz. Which might be tomorrow. What you are going to do today is you're going to turn the page over and you're going to do two things. You're not going to follow these instructions exactly as they are written. You are going to list the square or cube root of each number. Now you will notice some things in here. This is, that's not what you just showed us, Mr. Myers. I'm going to ask you to use what you know about math to see if you can figure these out. Here is what you will do on page 27. If it is perfect, for all perfect squares, you will write, or perfect cubes, you will give me the perfect square of the cube. Don't use a calculator. You don't need to, because you have all the numbers written. Okay? If it is irrational, then you don't get to cop out and just write irrational. You must give me an estimate. And that is what we just did on the last page. Okay? That's your job for page 27. Everybody cool? Don't start it yet because I'm going to give you instructions on page 28 too. Turn the page over to 28. On 28, okay, on 28, I'm going to give you again, no calculators, because I want you to see if you can figure it out, because you can. And I'm going to ask you on 28, I'm going to allow you, if it's irrational, just to write irrational. Okay? But don't cheat. All right? Now, the thing you need to do this properly is you need to remember this fact right here. The square root of 400 happens to be 4 and 100. So you can work out the square root without touching a calculator. Okay? Everybody good? I know that me saying no calculator is making some of you twitchy. That's okay. You're going to be fine. Especially after tomorrow when you learn how to do this completely without a calculator and do it right. The way every teacher from now on will want you to do it. You will almost never use that button again. Okay? Go. Are you allowed to move around? Yes. Can you work with friends? Yes.